Group 11, the life cycle of stars, take 735. What are stars and how are they formed? A star is a large sphere of hydrogen and helium with enough mass that can sustain nuclear fusion at its core. Simply put, a star is a large ball of hot glowing gas. All stars start out as nebula. Nebulas are gas clouds which contain helium and hydrogen. They contain a gravitational force that soaks in the surrounding gases. The star is created when 4 hydrogen atoms form into 1 helium atom in the nebula. Most stars are about 90% hydrogen and 10% helium. However, stars may have many various elements in them. They start out as hydrogen and helium. Stars are created by particles slamming together to fuse a new element. Every time a new reaction or collision takes place, the star gains energy and light. In scientific terms, this is called nuclear fusion. This fusion will create carbon, nitrogen, oxygen, and all the way up to iron. Nuclear fusion occurs when atomic nuclei collide and create a new atomic nucleus. This process creates photons, which are stars' source of energy and light. The core of the star becomes denser as fusion continues. As fusion continues, the star will become larger. The more chemical reactions that take place in the star, the brighter and larger they will become. So this is just a minuscule model of nuclear fusion. So after this, a star can no longer sustain hydrogen in its core and a period of instability begins. This is the beginning of the end. Its core will begin to fuse helium atoms for energy to build heavier elements such as carbon to oxygen and all the way up to iron. When the star creates iron, nuclear fusion can no longer take place. Once the star expands because of fusion, the outer regions of the star grow colder as they get further from the core. The star expands and the temperature drops. This results in what we call a red giant. These red giants go through many periods of instability, which throws elements from its surface. These materials form a small nebula around the star, then form a white dwarf. A white dwarf is a very dense star no bigger than Earth. Over millions of years, a white dwarf will cool down because no nuclear reactions are occurring and it will become a black dwarf. This is the end of an average star's life. So we have covered the average stars, and now we'll move to massive stars. So once again, they're created in the nebula, and then the star is created. And then once again we have a supergiant, similar to the normal red giant. So different from the other star is a supernova. A supernova is the explosive death of a large star. When a massive star runs out of nuclear fuel, there is no way to sustain them through their own weight. The central part of the star collapses and the outer layers are pulled into the core, and this results in the explosion. This massive explosion creates another nebula. The hydrogen gas in the nebula can create more stars, so the remainders of stars can create new ones. After the supernova, the core of the star remains. From here is where the star has two paths depending on its mass. If the star's mass is large enough, it will form a black hole, but if not, it will become a neutron star. A neutron star is about 1.5 times the mass of the Sun. The star is around 12 miles in diameter, but a teaspoon of the star's mass will have about the same mass of the Earth. These stars are made mostly of all neutrons. You could consider one neutron star to be one giant nucleus of an atom made of neutrons. For large mass stars, well, this is a neutron star compared to Earth and a white dwarf. Large mass stars will create a black hole instead of neutron stars. A black hole is a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star dies. Because no light can get out, we can't see black holes. They are invisible, so how do we know anything about them? Well, we don't. Most black hole information is either gathered by speculation or theories. Many scientists that study black holes cannot verify their information because they cannot see it. And this is just another picture of a black hole. And here are works cited. And if you didn't learn anything, at least you get to watch the full Return of the Jedi. I believe this is Return of the Jedi. Thank you for your time. Group 11 out.